Hello students, today we are going to discuss about the kinematics problem. A stone is dropped into a well and falls vertically with constant acceleration where the acceleration is constant and we are taking it as the value of acceleration due to gravity, that is 9.81 meter per second square. Now the sound of impact of the stone on the bottom of the well is heard 6.5 seconds after it is dropped. If the velocity of the sound is given in the question as to take as 336 meter per second and is saying to find out how deep is the well. So related to this particular question, let us formulate a particular diagram for this. Assume that this is the well, where into the well we are dropping a stone. Now we know that whenever a stone is dropped, we are not applying any kind of force on it, simply we are actually dropping it. So when we drop it, the initial velocity of the particular stone, which is taken as 0, so u is equal to 0. Now this particular stone, when it is dropped, clear, due to gravity it moves in the downward direction, and in this case when it touches the surface of the water, as you can see over here, when it touches the surface of the water, a sound is created. Now that particular sound actually travels to your ears. So the thing which I am drawing now is actually the sound which is actually traveling to your ears. Supposing that if you are taking T1, T1 is the time taken by the stone into the well and T2 is the time taken by the sound which is to be heard and which you are hearing it with the help of your ears. So here we have to find out what is the depth of the well as shown in the diagram. For example, the depth of the well we'll consider it as S. This S actually we have to find it out. Remember one thing, whenever the stone is dropped, it goes in the downward direction. When it touches the surface of the water, after touching the surface of the water, the sound is actually traveling, okay, by taking the time T2. So by keeping in reference to this particular diagram and the velocity of the sound is also given to you, we are going to solve the problem. Now, what is the given data? The velocity of sound is given as 336 meter per second, which let us take it as capital V, and let S be the depth of the well. Okay, and as already said, T1 is the time taken by the stone into the well, and T2 is the, as you can see here, T1 is what? Time taken by the stone into the well is going in downward direction as shown by the arrow mark, and T2 is the time taken by the sound which is going in the upward direction. Time taken by the sound to be heard. Okay. So as given in the question over here, that after the impact of the stone on the bottom of the well, we are hearing the sound after 6.5 seconds after it is dropped. So from that information we can say the total time the total time taken by the stone, the total time taken by the stone into the well, and you can say the sound of impact. Okay, so that total time we can take it as t, and the total time taken by the stone into the well is your t1, and the sound of impact, that's time taken by the sound to be heard, is your t2. So t is equal to t1 plus t2. Okay, so as already given in the question, so t1 plus t2, the total time taken the sound to be heard is 6.5 seconds. So this is the important equation. Now what is the initial velocity? Because the stone is simply dropped, the initial velocity is 0 here. And we know the equation S is equal to ut plus half at square. So instead of A, we are taking as G because it is simply dropped, it is towards the gravity. So A is here, A is nothing but we are taking as A is equal to plus G. Okay, so as the initial velocity is 0, so S is equal to this particular part becomes 0. So S is equal to half G T1 square. Okay. So what is T1? Time taken by the stone into the well. So ultimately we get T1 is equal to 2S by G root over. So this let us take it as equation 1. Now similarly, we all know that sound travels with uniform velocity. Okay. So for uniform velocity means acceleration is 0. So similarly, the same equation that we are going to use, that S is equal to ut plus half a t2 square. Okay, or ut2 you can write, because this is you are traveling for the sound. Because this a is 0, so this portion becomes 0. So finally we get S is equal to v t2. Why we are transferring v? Because this particular portion v we have taken as, here you can see that the velocity of sound is v here. Okay, so here S is equal to v t2. So what is t2? So t2 is equal to S by v. Okay. We know that already that t1 plus t2 is equal to 6.5 seconds. Okay. So what was the value of t1 we got? The value of t1 was root over of 2s by g. The value of t2 is s by v is equal to 6.5. Okay. So we'll get 2s by g is equal to 6.5 minus s by v. Open the root over, so it becomes whole square on the other side. Okay. So after this particular calculation, we know the value of G, that we have to take it as given in the question, 9.81 meter per second square. This S you have to actually find it out. Then the value of V is also given as 336 meter per second. So substitute all these values in this particular equation. So after substituting, we are going to get this particular equation, that is 0.2038 S is equal to 42.25 plus 0.12345 S square. This is what we are getting from here, minus 0.0387 S. So this is somewhat like a quadratic equation. 88 S square minus 0.24257 S plus 42.25 is equal to 0. This is a quadratic equation. Directly you put this quadratic equation into your scientific calculator, then ultimately we are going to get this particular value. Okay, so already you can see here, after calculation I got the answer as S, that is the depth of the well is 174.43 meter. Kindly verify your answer. Thank you.